Recall that the differential equation together with the initial condition is called the initial value problem, IVP. So for example, given the differential equation dw over d theta equals theta w squared sine theta squared, and the initial value when theta is 0, w is 1, this is called the initial value problem, or IVP. We're going to use separable equation to solve w, and we're going to use the initial condition to find the particular solution. We move all the expression with w in it to the left hand side, and all of the expressions that had theta on the right hand side. And then we integrate both sides of the equation with respect to corresponding variable. On the left hand side, it is the antiderivative with respect to w, and so it is minus 1 over w. And the right hand side, to find the antiderivative of theta sine theta squared, we can use substitution, but we can guess that the antiderivative of theta sine theta squared is minus cosine of theta squared divided by 2. Note that if I take the derivative of minus 1 over w, I would have negative 1 w to the negative 2, which is good. And if I were to take the derivative of negative 1/2 cosine of theta squared, I would get negative 1/2 times negative sine of theta squared times 2 theta. Theta stays, 2 cancel out the 2, which is good. We still need to add a c. The question doesn't ask for a general solution. Given the initial condition, we're going to use this initial condition to isolate w to obtain a particular solution. Minus 1 over w, but w is 1, equals negative 1/2 cosine, but theta is 0, plus c. And that is, when theta is 0, w is 1. We then simplify this to get negative 1 equals negative 1/2 plus c, so c is minus 1/2. Minus 1 over w is minus 1/2 cosine of theta squared plus c, but c is minus 1/2. Negative 1 over w equals minus 1 cosine theta squared minus 1 over 2. We can get rid of the negative to get 1 over w equals cosine of theta squared plus 1 over 2. And then we flip both fractions to get w equals 2 over 1 plus cosine of theta squared. And this is the particular solution to this IVP problem.